So hello everyone. Okay, let me check. Am I audible? Okay, am I audible? Okay, am I audible right now? Yeah. Okay, so we can start the session. Sorry for some delay. Yeah. So hello everyone. Welcome to Tech Drill by GDGWDM Jalandhar. My name is Richraj and I'm an organizer for GDG Jalandhar, and I'm also Google developer expert for web technology and Firebase. Also, I'm running a YouTube channel named is Tech Ferment. And at GDG Jalandhar, we have started this initiative named is Tech Drill uh, for helping our members to continue their learning from anywhere. So this initiative is aimed to provide 7 days training session on various developer technologies like Android, DWA, Firebase, Flutter, Web, from basic to advanced level. And you can check out more details about the tech drill at our website techdrill.gdgjalandhar.com. This is the website. Here you can check out the events or you can find more information about tech drill. To know more about community updates, latest announcement about the product and initiative by our community, you may join our community with the link at gdg.community.dev/gdg-jalandhar. We will share the resources, newsletters, and more informations to our members regularly in a month. So before going to start this training or sessions on machine learning, so we have some code of conduct for you all. So first one is be nice, respectful, and constructive. And while interacting on live chat or any other social media platform like Discord. Do not post anything if there are any adult content, rude, offensive statement. Do not advertise or promote anything. And the fourth one, do not spam. Fifth, harassment of any kind is not tolerated in this event. And according to the code of conduct, you will be blocked for interacting on the live chat and this entire video call session. You can report to the gdgjalandhar@gmail.com if you find any see anything incorporate. You might like during the sessions you might be having some doubts or issues in this training. So for interactions, we have Discord channel. You can join Discord, GDG, discord.gdg.com, gdgjalandhar.com. And here we have a channel, Machine Learning 01, where you can directly reach out to the members, like members, mentors, if you have any questions or confusion related to machine learning. And yes, we have a certificate. For that, you need to complete a project, which will be assigned by the mentors. Within you have to complete this particular task within a given time of period. And once you complete your task, we will provide a certificate for the completions of machine learning. And this is a new platform for this particular machine learning series. So this platform is JDG video call features. So in the right hand, we have a sidebar. So in the sidebar, you can see the chat section. So first section is for the general, where you can message anything related to general questions. And then we have another tab. Now you're able to see the tab Q&A. So if you have ask your questions in the Q&A sections, our mentor your questions from the Q&A sections, and then you can get your answers. So without much delay, I would like to invite Ravi Rana, who is BSc lead for CGC for year 2020 and 21. And he has done a lot in the machine learning. And trust me, I also learning machine learning from his through this journey and the experience. So without much delay, over to you, Ravi. I'll just invite.
Hello, hi. I'm audible. Hi, hello everyone. My name is Ravi Rana, and I'll be your mentor for machine learning for this tech session. And let's start with this. So let me just share my screen. Okay, is my screen visible to all of you? Okay, so for today, our topic is let's start with machine learning. So without further ado, let's start. So first of all, about myself, my name is Ravi Rana, as it has been stated earlier. So I was the DSC lead for Chandigarh group of colleges for the session 2020 and 21, and I have been practicing machine learning for past two years. I was first selected as the Explore ML facilitator for Chandigarh group of colleges under the DSC Explore ML program, and I have been trained on TensorFlow and machine learning, and I'm practicing. I've published some research on machine learning also, and have few patents on the technology. So if you want to connect with me, this is my Twitter handle, Ravi_Rana. And I'm also a keen football fan. So if you want to talk about machine learning or football, you can DM me on Twitter or LinkedIn. So let's get with overview that what we'll be covering in the 7 days training on machine learning. So this is the agenda for the 7 days. So today we will covering what is machine learning, the basics of machine learning, that how and when it was started, and how is it implemented, and where to use machine learning. Tomorrow and on day 2, we'll be talking about linear regression. Linear regression is a concept in machine learning. For people who are somewhat familiar with machine learning, they might be knowing that. And for people who are not, don't worry, we'll cover it today about the basics of linear regression. What is linear regression? And on day 3, we'll study about exploratory data analysis. So EDA, or exploratory data analysis. So what is EDA is about? So before using data for your machine learning models, you have to derive in meaningful insights from it. So on day 3, we'll cover that. And on day 4, the linear regression continued. We'll develop our own project, our own model, machine learning model, and further details are given on that day. And we'll on day 5 and day 6, we'll study about classification in machine learning. And on day 7, we'll talk about natural language processing. We'll cover the basics of natural language processing. So without further delay, let's start. So before learning that what is machine learning and how is it implemented, the first question must be why. Before learning any technology, the first question is why that technology. So hence starting with it, that why machine learning. So most of you might most of you are familiar with it, that what is machine learning and why machine learning, and some of you will be completely beginners in that field. So why machine learning? See, there are certain scenarios in our day-to-day life when the traditional rules are not of use while making a software, or while while solving a problem. So what are the traditional rules? What is so I've been I will be using a word, the rule-based programming or traditional programming, a lot throughout the 7 days. So let's first understand what is traditional or rule-based programming. So the traditional or rule-based programming is defined as a set of statements, that set of if-else conditions. Let's say that you are making a program for a calculator. So there you define certain rules, that if the user inputs say 1, you will provide him addition. And if he inputs 2, you will provide him subtraction, and so on. So you define rules for rules for that program. You define rules for this software. So this is called traditional rule-based or programming or rule-based approach. So there are certain scenarios when this rule-based approach is not viable, when this rule-based approach is not valid. So let's see one of example that I've mentioned in this slide. So you cannot hardcode a keyboard to predict what might a person type next. So what is the technology that predicts what the person types next? Yes, it's autocomplete feature. So you cannot hardcode it. Can you think of the if and else statements that would go into that machine? That can you think of that if and else condition that would go into that program or software? No, right? Or if you were able to think an if and else model for that, it would be a huge nest and it would be a huge mess. And moreover, it would only be able for one person, because every different person will have their own writing styles, they have their own features, they have their own uniqueness that you need to incorporate in your machine, in your software. So that is a paradigm that where the traditional rule-based approach is failed. So these are certain scenarios that where you can apply machine learning. And talking about another example, let's take a very rudimentary example, that uh, differentiating between an image of a cat and a dog. So differentiating an image of between an image of a cat and a dog. What you cannot hard code a computer program to do that for you. If just think about it, what features can you give? What features can you give? What if else condition would be beautiful program for that? So what you can do, so for that you would make a machine learning model. So now let's start. But what is machine learning? Let's start with a rudimentary understanding, a rudimentary definition of machine learning. This is a Wikipedia definition of machine learning, that machine learning is the study of computer algorithms that improve automatically through experience. So let's talk about it. So machine learning is the study of computer algorithms that improves automatically through experience. Right now it is just a statement for us. For most of you it might not even make some meaning. So how machine learning works? So for that we will study the rule-based approach. So we will study this example. This is a very famous example that you can use for that we use for explaining machine learning. If you are gone on YouTube and watch Lawrence Maroney's videos, that it is elaborated in that also. So let's talk about that. What is this rule-based approach? So let's see, we are given a scenario that we have a girl, and we know that if she walks less than a speed of 4, the status would be walking. So you make a machine learning model that you make a simple rule based approach that if speed is less than 4, then the status would be walking. So now the the problem set ahead gives you another condition that now you need to incorporate a scenario where the girl is running. So what would you do? So you would write that. So you can add that, no problem. I'll just add an else condition that if speed is less than 4, the status would be walking, or and else the status would be running, because we have two conditions. We have only two conditions, that if speed is less than 4, the girl is walking, and if speed is greater than 4, she might be running. So now I add a third condition for you, that what if the girl is cycling, but I give you another parameter the the girl is only cycling if her speed goes more than 12 kilometer per hour. So if speed is less than 4, the status would be walking, and you will modify your previous condition that else if speed is less than 12, the status would be running. If speed is less than 12 and greater than 4, and the status would be running, and else the status would be cycling. So you have written a program for that. So now I give you another condition that can you write a simple rule based program for if the girl is golfing? Do, how many conditions would go under? How would you define conditions for saying that? How would you define the conditions that would define that the girl is golfing? Can You can't think of any condition that golfing would include moving in a golf cart. Golfing would include, yes, someone in the chat box said infinite conditions. Yes, it would include infinite conditions for that. There would be golfing would include some aspect in golfing would include running also. Some would include walking, and some would include traveling in a golf cart. So you can't make a rule based approach in defining if the girl is golfing. So someone in the chat box said, Ankit in the chat box has said that body languages. So how would you define the body languages? You have a condition speed that we were using in the past 3 scenario. At what condition are just you would you give to define the body languages? So that's exactly what we are talking about. Swing of the bat. So and computer vision. So computer vision is an aspect of machine learning only. We are talking about simple rule-based approach. And the swing of the bat. Swing of the bat would not define that if the girl is walking or not. We are not talking about that if the girl might not be swinging the bat the whole time while she is golfing. But if the girl is cycling with speed of 5, machine predict greater than running. Sorry, I'm not able to understand that. Let's maybe whether the girl is holding the golf club. How would you define a condition for that? You are talking about rudimentary things. Just think about how would you define a condition for it? How would you define if a girl is holding the golf club? How would you say that to a machine learning in if else based approach? Okay, so I've got it's more like impossible, not possible. So but what if there is a hill and the girl is moving at the speed of now we are talking about arbitrary condition, and our discussions would go off track if we diverge further into it. So coming back to our golfing based approach, so what now we can do to solve this problem if the girl is golfing or not? So let's revise what is rule based approach. In rule based approach, you give the rules that here the rule was if speed is greater than 4, if speed is less than 4, etc., and you provide them data and you provide the value for speed, and the rules and data give you answers. So how it differs to a machine learning based approach? In a machine learning based approach, you provide answers beforehand. So it might be a little confusing for the people who are new to machine learning, that how could we provide answers beforehand? So what we do in machine learning, what we did in rule based approach, we provide a condition, we provide rules. So now in machine learning, what we'll provide answers and data. So yeah, many of you are saying supervised learning, that you might be familiar with machine learning, but let's talk about a basic beginner level stuff, that what would we mean about providing answers with data. So what we can do is let's analyze the previous movement of this girl. if we are going to predict the girl is playing golf or not, we take previous data for her. So previous data would be that if the girl is doing this things, if a girl is going sitting on a golf cart for this period of time, if a girl is going through is running for this period of time, if the girl is walking for this much time, so that would be providing answers, and that would be providing answers with data, and that would be providing data. So we will label the data that if the girl is doing such things that I have listed above, listed before, and that would give, we would label it that she is golfing. Okay, so am I clear? A little yes or no in the chat box, if you get this approach, that how we are providing the answers with data. So I'm going to repeat it just in case. So in machine learning based approach, what we do, we give the machine learning model data. We give the previous data of the girl to the machine learning model. So what data would we give it to her? So let's say we gave her previous 5 years, previous 5 days golf playing data. That while the girl plays golf, she does this thing, that she walks for this minutes, she travels in the golf cart for this minute, and she's runs for this minutes or this much hours. So, and we label the data with that, if this is going on, and that if these things are going on, that then the girl would be playing uh, golf. So we provide that to our machine learning models, and our machine learning model extract rules from it, extract condition from it. So whenever we add an approach, so whenever we add whenever we add a new question for it, that now tell me that if the girl is playing golf or not. So these rules will be extracted from the previous data, and our machine learning model would give this answer, that um, will give us the answer that if the girl is playing golf or not. So coming on to the doubt section, that what happens if no player had played golf yet? That is, if it is the first player playing golf. So that that would be the first step in machine learning. That would be called data collection. We diverge it further. Do not go into technicalities just yet. If there is no, we are just talking about where machine learning is used. Just assume their data is present. If the data is not present yet, actually the first step of conducting or making our own machine learning model is to be getting the data. So we are here assuming that we have data. So, and I've also said that we would collect that data of that we would collect the previous 5 days data of her playing golf. So that's how we get data. We get a machine learning models to make rules for us. So am I now clear? Okay. So now, to summarize, what is rule-based approach and what is machine learning? So in rule-based approach, rules are defined, that we have defined that if the speed is less than this and much, and if the conditions are defined, and improvement, where we can improve. So, improvement comes from algorithms and networks. You can add more conditions so that your rule-based approach model is improved. And not talking about machine learning, in machine learning we learn patterns from data, and improvements can be made from additional data. So how are we learning patterns from data? So in previous slide we saw that in the machine learning model we provide answers with data, and the machine learning model gives rules to us, which we applied on a new set of data. So this process of extracting rules from the answers and data from the data set is it involves learning patterns from data. A machine learning model learns pattern, that what patterns would we make in our previous example that would help us in predict that the girl is playing golf or not. So now improvements can be made from additional data. So how this state improvements can be made from additional data. So improvements, when you provide more data, you would have you would have more experience about how the activity of the girls varies while playing golf. So the patterns would be more clear, and hence our machine learning model will be improved. So, hi, Kalesh have been saying that can I know what is the difference between ML and neural network? So, difference we will cover that in subsequent slide. Don't worry. So, let's AI or ML. So, let me tell you, they are not the same. Weber was saying, but larger data can even confuse the model, right? So, yeah, the greater the data, but it is up towards that how we are using that data. uh, you can even use the data, you can even a small data set, but if you use a large data set, you are going to learn you that you would use the data set and derive the meaningful insights from it. So there is no such thing, if larger data set is used properly, it would not confuse our model. Okay, so AI or ML. Let me tell you that they are not the same. And now here we come the difference between artificial intelligence, machine learning, and deep learning. So what is artificial intelligence? So artificial intelligence is a technique which enables machines to mimic human behavior. It is a superset. Artificial intelligence is generally a superset. Many of the new beginners, uh, many beginners are like that. Many beginners say that AI and ML are the same, but they are not the same. Artificial intelligence is a superset of machine learning. So, what is artificial intelligence? Artificial intelligence is a technique which enables machines to mimic human behavior. So, artificial intelligence would also include things like robotics and including robotics with machine learning technologies, and including robotics and IoT based technologies with machine learning models. So that is called artificial intelligence. It is a superset of machine learning and deep learning. So let's now talking about what is machine learning. Machine learning is a subset of artificial intelligence, and which are and it includes statistical methods to enable machine to improve with experience. So this is a mathematical statement that it includes statistical methods to enable machines to improve with experience. It is a confusing statement. So uh, let's putting it simply that machine learning is a subset of artificial intelligence, and it includes algorithms, various mathematical algorithms, and that helps us in prediction or classification or various applications of machine learning. So machine learning is using maths behind it, and it is a subset of artificial intelligence. And now let's talk about deep learning. So what is deep learning? So deep learning is a subset of machine learning, and it uses a concept called neural network. So neural network, when say that they try to, in layman's term, if we are talking about in a common layman term, that what is a neural network? Neural network is is like a neuron present in the brain, but it is not entirely correct. A a neuron that is present in our brain that does many things. It does many things, but a neuron in a neural network try to emulate the process that the neuron in our brain does, and it also uses mathematics behind it. And we'll cover deep learning in our advanced ML classes, in our advanced ML track of these ML trainings. So that is the main difference between artificial intelligence, machine learning, and deep learning. They are Artificial intelligence is the superset of machine learning, and machine learning is a super machine learning and deep learning. Artificial intelligence superset of machine learning and deep learning, and machine learning is a superset of deep learning. Okay, so is this differentiation clear? Please shoot a yes in the chat box. Okay, so now let's just address the most important thing that we talked in the previous slide, that machine learning uses mathematics, and that machine learning models are nothing but mathematical models that we use for prediction and for stuff and for the applications of machine learning. So let's discuss what is the role of maths and machine learning. So machine learning models are nothing but statistical, probabilistical, and computer science and algorithmic experts. So what this complex statement states. So a machine learning uses various algorithms, and these algorithms are nothing but mathematical equations, statistical model, probabilistical model. So let me give you an example. I'm assuming that most of us here are from a science background, that who have studied straight lines chapter in 11th class. So there we studied a really famous so there we studied a really famous equation that state that y is equal to mx plus c. Can anyone in the chat box give me answer that what this equation gives us? Y is equal to mx plus c. Straight line, yes. Y is equal to mx plus c is a equation of the straight line. So how we've talked about linear regression in machine learning. So why linear regression is nothing but fitting y is equal to mx plus c to various data points. So the algorithms that we employ for machine learning are nothing but statisticals and probabilistic models that uses maths behind it. Okay. So this, so here you can study that. Here you can see that maths is deeply connected to machine learning, and you need some rudimentary knowledge of mathematics if you want to study machine learning. If you want to study machine learning, see, the thing is that you can learn about machine learning without having a great background in mathematics, that without having a great understanding in machine learning. But according to my experience, that if you have a understanding of standard high school mathematics, you would be able to learn, yet you would be able to understand what your machine learning model is doing, and what your machine learning model, how you can improve your machine learning model by changing some parameters in your algorithm. So I have a question in chat box that states that difference between ML and data science. So ML uses ML. The definition of ML is using mathematical concept, mathematical algorithms to classify the data. Uh, uh, Classification is an example of machine learning to prediction of a new value, and uh, and various applications of machine learning. So whereas what is data science? So data science is a field where you derive important insights from data. You may or may not use those insights to get exact to make machine learning models, but you derive insights from the data. So this is the main difference between the data science and machine learning. So let's now talk about what is the machine learning process. So please give example of ML and DS. Okay, so what is data? So we are talking about the example of machine learning, that you can classify the images of a cat and dog, that you can get, that it helps in prediction. And in data science, suppose you are running a company and you want to know that which certain aspect of your sale of your product is generating more sales of the product for you. So you have a various raw data for that. You have a large data for various, let's say you have a data for previous 6 months of selling history and buying history, and what you do, you derive insights from the data, that which feature of the model which feature of the product makes it sell the most. So the deriving of this meaningful insights from data is underlying concept behind data science. Okay, I hope I'm clear. So let's now talk about machine learning process. So what is this machine learning process states? That first of all, we have raw data. And what is raw data? So in some slides earlier, we talked about, I had some questions regarding that, what if we have no data of or if the girl is playing golf? So collecting raw data is a part of it. So collecting raw data is the first part of the machine learning process. So what is raw data? Raw data is I've gotten a chat box. Raw data is unordered data. Raw data does not have any structure. Raw data includes many aspects in it. Let's take an example for this whole process. Let's suppose we are making a machine learning model that helps us in predicting the price of second hand cars. Or okay, so we have raw data in it, and mm, what would this raw data include? The raw data would also include the name of the owner. Raw data will include all of the information that would be in that machine learning, that that would give us, that would help us in this prediction of prices. So raw data will includes all of the information, and it may or may not include features like that we do not use. So suppose you are given a feature, a column in it that says the name of the owner. So just a simple yes or no in the chat box, that do you think the name of an owner would play an important role in predicting the price of that car? Yes, as I expected. No. So that where pre-processing kicks in. So we have our raw data, we have our unstructured data that contains the data values that which are not required in that it which are not required. So what do? We pre-process it. We remove this unwanted data points like the name of the previous owner. And now we, after doing pre-processing, we have a structured data. So what would be structured data? Would be defined as the data the in which all of in which all of the data points would give us the same, would give us an answer, would give it, would points us to the useful answer. Okay, so that would be a structured data, that all of the data points would result in an that would play an important part in our machine learning model. So what would we do? So now we will employ a learning algorithm on it. So here, let's talk about, we will employ linear regression on it. Okay. So now we have we employ linear regression on it. Now we have a candidate model. So what do candidate model defines? A candidate model, a candidate model is the type of a machine learning model that that is not deployed anywhere. That it gives correct answers, but it is not usable. So suppose now that you are making a that it is that predicting the price of a used car is the main product that your company provides. So would you give your customers a machine learning model that they are not able to use? So to be so to make that model usable, what would you do? That you would deploy the selected model. What does deploy selected model means? So deploy selected model means hosting your machine learning model to a cloud-based service where you can use retraining pipelines. So what is retraining pipelines? So suppose I come in, yeah, someone from the attendees have made this machine learning model of predicting the price of the cars. So I come in, I enter I enter data points, I enter the data for the car price that I want to predict, and I get my prediction. So what would I enter would not be, is not present in your in your date in your structured data. So what would now do, you would include that my entry into your raw data, you will pre-process it, and you will also enter into a structured data, and it will get in structured data. So the whole process the whole process is repeated. So this whole process uh, is called retraining. So what is about candidate model? So what is a candidate model? So suppose we have made a regression model we have used simple linear regression that gives us the answer, that gives us the price of the second-hand cars. So that would give us a candidate model. So what is a candidate model? So a candidate model is a machine learning model that gives the entire that gives the answers, that gives the correct answers, but it is not usable. It is not usable by a general person, by a person who is not familiar with the technology. So suppose a candidate model can be anything. It could be a command line. If possible, can use some sketchboard, so I believe it gives more clarity. Yes. Let's talk about first candidate model, then I'll answer that. I'll get back to the sketchboard thing. So this is a candidate model. A candidate model is a type of machine learning model that gives you a correct answers, but is not usable for many people, not usable for laymen. That is not usable for someone who is not familiar with how to establish a machine and how to use a machine learning process to enter their own data points to get their own prediction. That a model, simply a model that is not deployed. Yes, Molly. So this is a gold. Can you please explain from raw material to golden model with one example? I just did, Rishikesh. I took the example of used car price prediction, and I just gave gave does describe the whole of the machine learning process. So to repeat, but in raw data, what would I have? In raw data, I would have data of car prices, of previous car prices, and features on previous car prices, like the number of seats, the number, the sitting capacity, the engine capacity, and features like that, that might help us in predicting the price of the used car. So in raw data, I would have everything. And but now comes in pre-processing. In pre-processing, I will remove the unnecessary data points. I will remove the unnecessary features. And now we will have a structured data with us. So what is structured data? Structured data is a type of data which includes valuable valuable features for us. It includes all the features that we could use for applying the machine learning algorithm on it. So now what would we have? We have a candidate model. So what is a candidate model? A candidate model is a machine learning model that would be not be deployed. So our learning algorithm gave us, after applying linear regression, we have a machine learning model that would help us in predicting the prices of the second hand cars. But this model is not deployed anywhere. It cannot be used by any customer of yours or any friend of yours who is not well versed with this programming terminology. So now you would deploy selected model. So you would deploy the model that would help predicting the prices of the car to a cloud-based service like Google Cloud Platform or AWS SageMaker, and that would give you a golden model. And then it would give us a golden model. So what a golden model is? A golden model is a machine learning model that that is deployed to a cloud-based service and can be used by anyone to get insights for their data points. So now I was talking about retraining. So what is retraining? Suppose a person comes in, enters his data points, and get prediction for his car. So this this whole data goes back to raw data, and it all is used in the training. It is used in retraining of the machine learning model. So to repeat, as we have seen in previous slides, that where I was summing up the difference between rule-based approach and machine learning-based approach, I said that improvement in machine learning comes from giving more data. So this is what retraining pipeline is helping us. In the data points that the users enter in the golden model, that they enter in the deployed model, again goes into the raw data, which is later used for again training of the machine learning algorithm with more data, that such that it improves its capacity, that it improves its accuracy. So I hope I'm clear with the machine learning process. Okay. Just okay. So now let's talk about the various applications of machine learning. So most famous application of machine learning is classification. Classification is the most common example of machine learning. Here we train what would our data set get, but how our data set would be defined. So in our data set, we would have the images of cats and dogs. Suppose we are making a classification model to classify between the images of cats and dogs. So what we'll do, we'll make a class. We'll get a data set. We'll get a data set that contains the images of cats, and we will label each and every image on which class they belong to. So this belongs to a cat, and the dog, and the one below it belongs to a dog. So we label these photos. So pay attention when I say label. So why labeling is necessary in classification? Labeling is necessary in classification because we need to we need we need to define to our machine learning model that what type of data it is dealing with. So we provided it, if you get a machine if you get an image that look like this, then it is a cat. It is necessary that our machine learning model knows that it if it is an image of a cat and dog beforehand. So now our machine learning model is trained upon the images of cats and dogs that are named accordingly. And when now you enter your own image, that you own custom image, it will give you an answer if this image will give you a is gi- uh, is belongs to a cat, or this image is of a dog. So how does it work? So the system determines which class or category an example belongs to. So whenever you upload that image in your model, so it determines that on which class this belongs to. So when I use word class, so which two classes are present when we are talking about the classification between cat and a dog. So those two classes are and one class called cat and the other is dog. So our machine what so how our output look like? So our machine learning model gives us an output of that this label, and it belongs to this class, that it belongs to the cat class or dog class, and a percentage of confidence. So which whichever of the class have the highest greater percentage of confidence, that would be our answer. That would be the answer, that would be the class our image belongs to. Okay, so this is classification. So how it works, we will cover it in subsequent days, Sushant. And now, what is regression? Do we need programming concept for ML? So what programming concepts are you calling us? Um, for making machine learning models in this week, we will approach making machine learning models with Python. So you need to be familiar with Python, so that you can make machine learning model. And we have just said, do we train the models by feeding different pictures labeled differently? You feed the models by giving it the pictures and the labels that you are going to include in your machine learning model. So in the previous example, we saw about that we were classification, but we were classifying with with uh, between an image of a cat and image of a dog. So our labels would include that only, that it is it an image of a cat or is it an image of a dog. So now let's talk about regression. So what is regression? So regression analysis consists of a set of machine learning methods that allow us to predict a continuous outcome variable. So what is a continuous outcome variable? A continuous outcome variable is a type of a variable that is dependent variable. So the variable that is dependent on other data points. So here, let's get back to that equation we have talked about. Y is equal to mx plus c. So quickly, just can you write in the chat box that on which which variables the value of y is dependent on? In y is okay. Yes, correct. We are get so most of you have given the correct answer x. So yes, y is dependent on x. So in regression analysis, we have various we have a dependent variable and we have various independent variables. So we predict the dependent variables. We predict what would be our dependent variable by that based on the values of the independent or multiple predictor variables. So we'll see regression in depth from tomorrow onwards, when we'll solely be talking about regression. We'll make a project also on it. So what is the goal of regression? The goal of regression model is to build a mathematical equation that defines y as a function of x variables. So suppose let us we take our example where we talked about the price of a second-hand car. So here, what is our y? But our y is a variable that we need to protect. So can you tell me that what is y here in our example of predicting the price of a used car? What is y here? Obviously it would be output. So but yes, it would be our goal, but what is y in the example of predicting the price of a used car? Cost, price, yes, exactly, price. The y would be the price of the used car. So what would be our x's? What would be our dependent variables? uh, condition, time use. So x or our dependent variables are multiple features which would define the cost of the car. So this is called a regression analysis, where we get y using where we get the output using various features. So now you can see how you can model the machine learning model, how you can make the machine learning model for the predicting the price of a used car. Yes or no? Is regression clear? The idea of regression is clear to you? Okay. So now let's talk about clustering. That graph is not clear. So Rishikesh, we'll cover regression and graphs tomorrow onwards. So here the graph is here the graphs just defines a straight line. Okay. So from tomorrow onwards, we'll see that how is this graph is applied to our machine learning models. Okay. So now let us see about what is clustering. Clustering is another application of machine learning, and clustering is clustering different types of data together. Clustering is making the clusters of different types of data. Okay, so now you must be thinking that we were doing the same thing in classification. Yes or no? That we were doing the same thing in classification, that we were classifying between two different types of data. So how clustering is different from classification? So I said you to pay keen what is clustering, Karthik is saying. So clustering is making cluster or making groups of similar type of data, or of similar type of data together, similar type of data points together, similar. Okay, so this is clustering. So suppose we have a classroom that have athletes, and that have programmers, and that have dancers. So suppose I go into that classrooms and I say that uh, the row one contain athletes, row two only only includes the dancers, and row three would only include the programmers. So we are clustering these type of different people together. So basically, yes, Yashu said that basically data with similar properties. Okay, so now so now I was talking about how clustering is different from classification. So see, in classification, told you to pay keen attention to particular attention to a word that I was saying. That what are we providing with the set of images? I'm getting to that, Shan. So, yes, Wally said it. Label. Yes. So in classification, while training our machine learning model, we are we are providing the accurate label for it. What is the difference between regression and clustering? So regression is used to predict the value uh, on basis of some dependent and independent basis of dependent and independent variables. Okay, and clustering is grouping together similar data points. They are very much different concepts. So now getting back to how clustering is different from from classification. So while training our classification model, we were using labels for different image types. Were we or were we not? Yes or no? We used labels for cats images and dog images. So here in clustering, we do not know that. Let's suppose here four colors are given in this image that is on your screen. So we did not know what four colors they belong to. Our clustering is a type of that cluster different colors together by learning by learning patterns, by learning similar patterns in them. No, Vaibhav, that we can see clustering which breed of cat. No. So in here, pay attention to this example. That here clustering we do not know the data belongs to which class. Here we have four colors, so we have four classes. We do not know what is the name of the four colors. So what would clustering model do? A clustering would automatically identify that which class this color belongs to, and it would group them together. So got the main difference between clustering and classification? Yes or no? I've said not clear. So which aspect of clustering is not clear to you? That, so let me just say again, while training our classification model, means it is vague classification. No, you cannot assign the term classification to it, clustering it. So it is just a sort of a confusion that clustering can't be set a subset of. No, it can't be set a subset of classification. It is yes, Muskan, it is a concept of unsupervised learning. So why it can't be set a subset of classification? Because in classification we classify, we tell the difference between two or more different kinds of classes. And in clustering, what do? We group the similar type of data together. So this is the difference between classification and clustering. In classification, we say that which data points belong to which class, and in clustering, we do not have the concept of classes. In clustering, we group together various data points that are similar to each other, and the machine learning model do it on its own, that it identifies patterns, that is patterns that makes two data points similar. So Nikhil, they said differentiate with examples. So in clustering, I said that we have the most optimum example of learning clustering right now would be the clustering four different types of colors together. So here we have four different types of colors. So let's suppose before clustering they were all mixed up, and you did not know. And I am a colorblind person. I'm a colorblind person. I do not know in what this four color represents. So what did I do? I ran a clustering algorithm. I ran a clustering algorithm through my data. And what did this algorithm did for me? It segregated. It clustered four different type of colors together. Okay. So clustering is grouping of objects, identifying, adding the groups of data points. So clustering is grouping of objects, that's correct. But classification is identifying that which class that data belongs to. And for classification, we used predefined labels. Okay. So now I hope this example is clear for clustering. So am I clear? Is clustering clear for everyone? So classification, so Weber says classification on those color would be applicable only if you are not colorblind. So saying that in more accurate terms, that if you are using classification, your machine learning, you must first of all uh, you must define to your machine learning model that what color red look like, that what is the name of those four different colors. Then they would be classified to the in various classes. But in clustering, even we do not know that in what is the color of those four colors, what is the name of those colors, to be accurate. So this is where clustering is different from classification. I hope, is it clear now? Okay. So now we are talking about sequence prediction. Differentiating between groups like animals and plants, does this come under clustering? So if you have, yes, it's come under clustering. If no, classification would, first of all, it would comes under clustering if you do not provide a machine learning model input that label that if it is that if this image is of animal or this image is of plant, and if you provide label to your data, so that would provide that would give that it would make it to a classification model. So basically classification is a supervised learning method, and clustering is a unsupervised learning method. So we'll talk about class supervised and unsupervised in the next slide. Okay, clustering with labels is classification. Yes, sort of. Man, thank you for the summarization. So sequence prediction. So what is sequence prediction for us? So let's move on to sequence prediction. We all are using smartphone nowadays. So what is sequence prediction for us? Okay, in while typing a message, suppose you are chatting with your friend, you are using WhatsApp for it, and you are using the pre-default keyboard for it. Let's say Google keyboard for sequence prediction. So your keyboard tries to predict your next word for you. It would give you accurate answer, or sometimes it would give you an inaccurate answer. Am I right? That this autocomplete feature is a really annoying feature of your keyboard, of your Android keyboard, and most of us have disabled it. So it is working on a machine learning concept that is called sequence prediction. So now what is happening in sequence prediction? So your keyboard learns how you type. So it tries to emulate you, and it gives you the answer of that what you might do next. And so how does it works? So it collects data as you type to your friends, with more increasing period of time it collects data, and it tries to predict that what you write after it. So suppose I have written a sentence that say that my name is Ravi. Okay, so I have written it now 3-4 times. So next time whenever I would write my name is, it would give me a suggestion that next word should be Ravi. So it learns your behavior. It's learn your typing input, and it learns your typing habits by collecting data from you. So it gets more accurate as we use it continuously. Yes, Nikhil, it is right. So how it gets more accurate? So more and more data. So we have discussed that how machine learning model get accurate. It by user how a machine learning model is improved. It is only improved when you provide more data. So with repeated usage, it gets more data to train on. So its its prediction makes more sense in the later days, since its initial days. Okay, so this is called sequence prediction, predicting new sequence value from old sequence data. So from now old sequence data from old data. So it try to predict new value. So the new values from the old from a various typing habits. So sequence prediction is clear for everyone. Okay. So now talking about style transfer. So what is style transfer? Here we have an image. So an image one consists of the houses that belong to Victorian era, and actually these three are portraits. So portrait one is of houses that belong to the Victorian era, and portrait two is a sort of a Picasso like drawing, that abstract drawing that Picasso made. Suppose you are making a machine learning model that generates uh, portraits of Victorian houses for you. So for that, what would you do? You would train it on the data set which includes Victorian houses. Am I right or wrong? Am I right or wrong? Yes. So now, if you use that, suppose I have trained a machine learning model on Victorian house dataset that for producing portraits that belong to Victorian houses, and I apply it to the abstract painting that goes into this model, that abstract painting types that were made by Picasso. So what would it do? It would give me a different type of images. So in the third image, you can see that the third image is a mixture of the Victorian era houses and the portrait that belonged to Picasso. So this is style transfer. When a machine learning model that is trained on a different type of data is applied to different type of data, it generates a new type of data. It is called a style transfer. So is it clear? Learn. Here some homework for you. Go to Google, learn more about style transfer, its application. Okay, it would learn more about various applications of style transfer, that where style transfer is used and could be used. Okay. Okay. So yes. So now, are there types in ML? Yes, there are. Somebody saying yes. Can we see YouTube? Yes, you can see YouTube. Just go on to internet and study more about everything that you have that we have learned today. Like things like regression, classification, the difference between clustering and classification, that most of us were having differences. Okay, so search more about it. Are we going to use this model or going to design it? Shashank, these we will cover these sort of models in advanced machine learning classes, where we will use deep learning models. Okay, so now here we are going to talk about beginner to intermediate level stuff, where we will be using regression and classification based models, making and using regression and classification based models. So sir, are you going to share this PPT? Yes, we'll share the relevant material with all of you. Okay, so now in machine, what is machine learning? What are the various types of machine learning? So machine learning is defined into two types: supervised and unsupervised. So I keep this slide at why I kept this slide at the end of the presentation is because now after learning about various type of application of machine learning, that you would be able to identify that what is supervised and what is unsupervised. So supervised machine learning is the type of machine learning where you provide labels beforehand. Okay, and where did we provide labels beforehand? In regression and classification based problems. And where we did not provide labels, quickly, where we can you give it the answer in the chat box? That yes, clustering. We did not provide labels in clustering. So hence the clustering is an example of the unsupervised machine learning. We did not provide labels in sequence prediction also. So that is unsupervised machine learning. So I think this makes you clear that what is the difference between supervised and unsupervised machine learning. Yes or no? Okay. So at the end of this time, at the end of this presentation, I would like to share this quote that I really like, and I share it in every class, that in every seminar that I take, that what we want is a machine that can learn from experience. So and he said that quotes in early 1930s, during 1920s and 1930s. So let me share an interesting anecdote with you, that how machine learning was used in the World War II to shorten the length of the war by 2 years. So there were two groups during the time of the World War II, the Allied forces and the Axis forces. The Allied forces consisted of uh, the nations like United States, the Great Britain, and the Axis forces consist of Germany, Italy. So now what happened, that in Germany they made a machine that was called Enigma. So what did Enigma did? So Enigma sent encrypted messages according to the various ships and the battle stations that were established by the German military. So it was very difficult at the time to decrypt the messages that was sent by Enigma. So Alan Turing and his team made a machine that was called Bomb, BOMBE, and it was the machine used various a sort of an algorithm that that made use of machine learning by that, or how it was making use of machine learning, it was learning from experience. So there it was, so hence machine learning was used in World War II, and according to a study it was said that it helped reduce the length of World War II by 2 years. So machine learning have been through us but through that time, and machine learning is not that new. Okay, so thank you. That's from my end for today. If you have any questions, you can ask it in the chat box. And yes, the imitation game. Yes, they in the movies, the imitation game movies based on the life of Alan Turing, but it is not entirely historically accurate. I suggest you read about Alan Turing. So if you have any questions, if you tell about certificate, please. So how the certificate would be given, that from tomorrow onwards, we'll try to get more practical implementations of machine learning, and that how you can make a machine learning model. And at the end, sixth or the seventh day, I will assign projects to you. And it would not be very much different from the projects that we cover in this week. And those projects, and those and if by completing, you will complete those projects and submit it, and I'll review those projects, and then you would get those certificates, and then you would get certificates. And what would we get the recording if possible? Yes, the recording would most likely be present on YouTube. So let me just check Q&A section.